Hey, hello guys, welcome back to my channel Golu Kavishkar, and guys, in this video I'm going to show you guys my I made a new project. So its name is Web ESC Control. So guys, in this project, I'm gonna show you, it can control your BLDC motors without any servo tester. You can control your BLDC motors with the help of your uh, node MCU ESP32. So this is the code. I will give you link of this code in description. So this code is used to drive the BLDC motor, as I said, but your node MCU ESP32 will only work as a servo tester, and this ESC control, guys, can be used with web GUI interface also. So here is the code. We are using Wi-Fi.h library, asynchronous TCP library, and ESP asynchronous web server library, and this ESP underscore server.h library. So you need to download these three libraries from Google, okay? And then I have declared this serial object as this debug port, and here is the I have declared this ESC object as servo object. So here this is the potentiometer value, like this is the value, like it is minimum value is 0 and maximum is 180. So this is the value that would be put it in your BLDC motors ESC. So with the help of this potentiometer value between 0 and 180 it will work, and this is minimum PWM value and this is maximum PWM value. Okay, pulse width modulation, I explained this in some of my previous videos, you can watch them. So this is ESP impulse break. So guys, there is a special function in this thing that I told you. It has ESP impulse break, EIB. Okay. So what this does is, if you are lifting a heavy object, okay. Let me just explain you here. Okay. So if you are lifting a heavy object, okay, if you are lifting a heavy object, and this is the motor and this is the propeller, and if you want to land it, and if you do 0% throttle at that same time, what it is going to do, like it will directly fall, okay. So to protect that, what I have done is make a EIB function in ESC impulse braking. In that, your a heavy object, like any object you can choose, your heavy object with the motor here. So your heavy object would be falling not with the zero velocity. It would be falling with, like, in 0% without the EIB. It is going to fall with the acceleration of g, 9.8 meter per second square. Okay, meter per second square. And in that, like which I told you, ESC impulse braking, this 9.8 would be halved, like half of it would be around 4.6, right? It would be 4.6 meter per second square. So this is the ESC impulse braking function. It is going to go at a lower acceleration. So there are a lot more functions here. This works in AP mode. Okay, you can edit the code to write it in STA mode. And this is the main web page, in which there would be a slider from which you can control this speed. And here is the main part of it, where like everything starts up. This is the AP mode here. Like, it's pretty easy, you know. So this is the impulse braking function. Here, this is the commands function. If you like to calibrate the ESC, you can calibrate it. There is normal mode, there is manual mode, there is impulse braking, enable, disable option, ESP calibration. I told you, like, these are the functions. So now I have uploaded the code in my ESP. Now I connect it and I plug in my BLDC motor with it. So first let me tell you the connection diagram, okay. So the connection diagram is pretty easy. you have two wires. Okay, wire 1, wire 2. This is your node MCU. This is your ESC. Let me write ESC node MCU ESP32. So here the ground pin of your ESC will go to ground pin of your ESP32, and the signal pin of your ESC will go to D15 of your node MCU ESP32. So now I have uploaded the code already, and now if I start the motor, wait, yeah, here we go. As you can see, motor starting. So now it will, now this is indication that the ESC is not connected, but I have connected the wires. So to do it, so to calibrate it, you have to connect to this ESC underscore MGMT with this password. Okay. And then you have to go to IP 192.168.4.1. It is fixed IP, and here first set it to full, then 0. As you can see, it calibrated. Now here, if I start it, boom, as you can see. Too much noise. But guys, as you can see, it works. Okay. So the motor rebooted. It restarted because I'm using 1.5 ampere current adapter, and it is not sufficient. So as you can see, guys, it works. So this is the code, and guys, if you like this project and if you like this video, so please subscribe to my channel and share this video to your friends if you have interest in it, and your friends also having interest in it. So stay creative, stay learning, and bye bye.